Picture the net like a sprawling city after dark. Neon signs everywhere, but you don't navigate by raw GPS coordinates. You roll by names. That's DNS, the system that translates human-friendly street names like algonquincollege.com into the precise IP addresses routers actually follow. Folks call it the internet's phone book, but that undersells it. It's distributed for resilience, redundant for uptime, and tuned for speed, so lookups hit quick, even when traffic's heavy. Under the hood, the naming game is hierarchical. At the top is the root, ACD, minimal anchor of trust. Below that, TLDs, the big neighborhoods like .com. K, delegate authority to zones, run by the domain's operators. Each zone is where the truth lives for that slice of namespace. Two key roles keep this moving. Recursive resolvers are the runners. They take your OS stub resolver's question and do the street-level legwork following referrals from root to TLD to the right authoritative name servers. Authoritatives are the librarians with the ledgers. They don't chase answers. They are the answers. Those answers live as resource records, RS inside zone files. Compact facts like HRA addresses, MX routes, NS delegations, all signed and timestamped when you need governance and auditability. To keep latency low and cost sane, most queries ride UDP on port 53. Lightweight, fire and forget. When the payload swells, think oversized responses or zone transfers. The protocol upshifts to TCP on 53 for reliable delivery and ordered streams. Put it together and you've got a naming fabric that decouples services from hard-coded endpoints, scales with the city, and keeps traffic flowing, even when the lights are bright and the streets are busy.
Let us commence with the only sensible place to begin. Definitions. A DNS lookup is not magical, nor does it involve the cloud in any meteorological sense. Your client application, say a web browser, delegates naming to the operating system's stub resolver. The stub resolver is intentionally simple. It checks its tiny local cache and, yes, possibly a host's file you absolutely shouldn't be using in production, then forwards the question to a network recursive resolver, typically run by your ISP, campus, enterprise, or a public service. Think of the stub as the inquisitive graduate student. The recursive resolver is the harried postdoc who does all the walking between offices. If the recursive already has a fresh answer, it returns it immediately. Fresh in this context is not a feeling, it's defined by the record's time to live, TTL, a numeric lease on truth. Caching is the difference between a system that scales and one that bursts into flames at the slightest hint of popularity. Short TTLs enable agility, failover, blue-green deploys. Long TTLs reduce latency and authoritative load. Choose them like an adult. In the entirely plausible event the cache is cold, the recursive performs iterative resolution. First, it consults a root name server for a referral, not an answer to the appropriate top-level domain, TLD, for example, .ca. The root's job is to delegate. It does not, contrary to many breathless blog posts, know the address of your cat blog. Next, the resolver asks the TLD. The TLD issues another referral to the authoritative name servers for the target zone, for example, example.ca. Finally, the resolver queries that authoritative server for the specific name www.example.ca and record type, say, A or A-tree-A. The authoritative doesn't chase anything. It is the source of truth for that zone. This is a hierarchy, not a democracy. All return data are resource records, compact tuples that encode fax addresses, mail routing, service endpoints. Most questions and answers travel via UDP's 53 because it's fast and stateless. When responses grow beyond comfortable UDP sizes or when we're doing zone transfers, we employ TCP 53. To minimize needless TCP fallbacks, modern resolvers use EDNS 0 to negotiate larger UDP payloads and set capability flags, for example, the DO bit indicating DNSSEC OK. Which brings us to DNSSEC. No, it does not encrypt DNS. It authenticates it. Through signatures, RRSEG validated against DNS key records and chained via DS records up the delegation path, DNSSEC lets resolvers detect tampering. If signatures validate, we accept the data as authentic. If they don't, we don't. Integrity, not confidentiality. You're welcome. For confidentiality of the query path between the client and the recursive, we have dot and DNS over TLS. DOT typically uses TCP port 853 and provides a dedicated TLS wrapped channel. DNS over HTTPS. DOH tunnels DNS within standard HTTPS, leveraging HTTP/2+ and ubiquitous port 443, which is convenient in environments where middle boxes are overly enthusiastic. Either way, the point is that observers on the local network can no longer casually enumerate your lookups. Please contain your applause. A final note on intellectual hygiene, negative caching. When a name doesn't exist, the authoritative returns NX domain, and the resolver caches that absence for a TTL derived from the zone's SOA parameters. This prevents repeated pointless queries for vacuous names or typos you refuse to admit you made. Absence too has a lifetime.
Names, my friend, are the pennants ships fly. Numbers are the latitudes that actually get you there. In our little ocean of packets, DNS is the quartermaster that turns a jaunty banner-like service, example.com, into coordinates you can sail to. The stock in trade is records A and a AAA are your charts to IPv4 and IPv6, respectively, while TAME is the alias a ship uses when it would rather you hail the flagship behind it. The mail boats follow MX beacons, delegations are posted with NS, and the SOA is the ship's articles, who's in charge of the zone and which serial the crew should be copying. TXT is where you scribble policies and proofs. SPF, DKIM, DMARC, SRV hoists a service pennant with priority, wait, port and target, do wave to _ Kerberos. _TCP as you pass, PTR reads the wake backwards, coordinates to name, and CAA tells the certificate mint which captains are allowed to request a seal for the domain. Now, a clever captain never sends the entire convoy to one pier if there are 3 open. With DNS we spread the landings, multiple A ounces share the load. Weights let you tilt traffic like ballast. GeoDNS steers nearby sailors to the nearest quay. And any casted resolvers are lighthouses sharing the same call sign at many headlands, so the first one you spy guides you in. That's, as the academics say, reduces latency and improves resiliency. As I'd say, fewer ships waiting, fewer tempers flaring. Discovery at sea is half the art. Savvy records advertise where a service listens, so clients don't guess the port like drunken navigators. Naptar can even rewrite your itinerary, regex runes pointing from one scheme to the next until you reach the right dock. When your hull or IP changes with the tide, dynamic DNS keeps the name lashed to the moving ship. And when you don't want outsiders seeing the same coastline as insiders, you keep split horizon views, 2 charts for one island. Private addresses within, public without. Security? We've signatures for that. DNSSEC doesn't wrap the message in velvet. It stamps the chart with a wax seal, RSEC verified by DNS key, chained by DSO. No doc hand swapped your orders in the night. If you need the path itself kept from prying eyes at the tavern, you take DORT or Duo for the client to resolve a leg. But that's another bottle. As for who may mint your certificate, CAA is the gate ledger at the mint. These authorities, yes, the rest be gone. And when the seas turn foul with brigands, you invoke policy. RPZ is your quarantine net. Domains known for trouble get rewritten or blocked outright, so gullible crew don't wander into cursed coves. To keep the fleet synchronized, the flagship authoritative sends its zone by AXFR, full manifest, or IXFR. Only what changed to the secondaries? A brisk notify, a signal flag, gets them updating before rumor outruns radio. There you have it. DNS not as sorcery but as seamanship, a bundle of plain mechanisms that, used with a bit of guile, keeps names true, traffic smooth, services discoverable, and rogues at arm's length. Now trim your TTLs for the weather you expect. Sign your charts and mind your views. Savvy?
The network used to aim by numbers alone, fixed coordinates welded into code, brittle and slow to change. DNS inserted a naming layer, human-readable labels mapped to addresses, so services detached from hard-coded IPs and became maneuverable. With that indirection, operators could rotate infrastructure, fail over, or scale out without rewriting clients. Agility emerged from simple rules. Delegate authority, cache with discipline, respect TTL. Once naming was abstracted, global distribution followed. DNS began steering traffic, not just locating it, multiple answers for the same name, weights to shape load, geography to minimize round-trip time, any cache to place identical resolvers at many edges, so the closest one responds first. Latency drops, resilience increases, the system keeps serving under stress. Trust for email moved into this fabric as policy expressed in records. SPF declares which senders are legitimate, DKIM signs the content, DMARC aligns identity and orders receivers how to act when alignment fails. All of it lives in TXT, verifiable signals attached to names, not folklore in mail relays. In the cloud era, the pattern extended inward. Private DNS in VPCs and VNets Route 53 Azure private DNS gave each environment its own authoritative truth. In Kubernetes, core DNS keeps service names stable while pods churn. Discovery happens by name, not by chasing ephemeral addresses. The name becomes the contract. Orchestration layers are free to replace the body behind it. Security intelligence learned to read the wake that DNS leaves. Telemetry from resolvers and passive DNS timelines exposes infrastructure reuse, fast flux pivots, and the synthetic churn of DGA domains. Response policy zones turn intelligence into control, rewriting or blackholing destinations at resolution time, so endpoints never reach hostile terrain. Meanwhile, confidentiality and integrity were split and solved on their own axis. Do-T and Do-H encrypt the path between client and resolver, removing casual observation from local networks and intermediaries. DNSSEC authenticates the data itself with signatures chained from the root through DS and DNS key, so a forged answer is detectable, even if the channel is visible. One protects who you ask, the other proves what you received. The result is a naming plane that functions like a strategic control plane. Programmable, observable, and defensible. Operators tune TTLs to balance responsiveness with stability, publish policies that machines can verify, and route users to healthy endpoints under evolving conditions. Systems change location, composition, and scale. Names remain constant. That is how DNS transformed networking, by turning identity into the lever and letting everything behind the lever move at internet speed.
If you want networks that don't crack under pressure, you name things and you route to the name. That's the whole move with DNS. For anything users or services need to reach reliably, your web front ends, internal APIs, mail exchangers, VoIP endpoints, even the domain controllers handling AD's Kerberos, give it a DNS name and make clients depend on that contract. The name becomes the handle. Behind it, you can swap machines, roll versions, fail over to another region, and nobody has to recompile code because you didn't tattoo an IP address into it. You do need to pick the right record for the job. When a thing has a stable network identity, publish A and AAA, that's the concrete mapping. When a thing is really just an alias AP riding on a load balancer or regional pool, use tname. But don't get cute at the apex of a zone. A bare domain can't be a CNAME without breaking the zone's other mandatory records, so lean on provider features like alias SA name there. For services where the port and priority matter, Kerberos SIP, the stuff that shouldn't be guessed, publish SRV so clients can discover without hard coding. And TXT is the little workhorse. Ownership challenges, SPF and other verifications live there, because text is flexible and machines can still validate it. Time is another lever. TTL isn't just a number, it's a policy. When you expect churn, migrations, blue-green, planned failovers, keep TTLs low so caches release stale answers quickly and you can steer traffic in minutes. When an endpoint is boring and stable, raise the TTL and watch latency and authoritative load drop because resolvers stop hammering you. Most teams end up with a mixed strategy: fast-moving edges with short TTLs, stateful backends with longer ones, and a playbook for temporarily shrinking TTLs before big changes. Inside corporate networks and cloud estates, DNS gets even more interesting. Private resolvers in VPCs, VNets, and split horizon views let you answer the same name differently depending on who's asking. Internals get RFC 1918 addresses for db.example.com. Externals see the public IP for the same label. That's how you avoid leaking your topology while still giving developers one canonical name to target in code and CI/CD. Compare that to hosts files or link local discovery protocols like MDNS, LL, MNR. Those are fine for tiny labs and one-off demos. But in an enterprise, they're an attack surface and an operational liability. A poisoned cache or a stray laptop advertising a fake service is how incidents start, which is why mature environments disable LLMNR and confine MDNS to constrained segments. And the cardinal sin, hard coding IPs, it feels fast in the moment. It's technical debt the second the topology changes. You lose agility. You can't rotate infrastructure without redeploys, and you sidestep all the policy and observability that comes with names. With DNS, you can layer in geo-steering, any casted resolvers, RPZ-based blocking, even TLS issuance constraints via CAA, all keyed to names. That's the play. Treat DNS as the control plane for identity and reachability. Choose records that match the semantics of the service. Tune TTLs to your rate of change. Keep private answers private with views, and resist the sticky note fixes. Names buy you time, flexibility, and control. Numbers alone just pin you to the floor.